Um, Good morning. Thank you for joining me again on our monthly Tech Women Power Breakfast. I'm so glad that you were able to join us. For those of you who are new, I am Heather Ledoux. I am the chair of the Tech Women Power Breakfast. And for my day job, I'm the executive director of professional programs and partnerships at Franklin Pierce University. So thank you for joining us. If you are new, just type in the chat box and let us know that you're new to our breakfast, and we can give you a warm welcome. And thank you for joining us. For our regulars, I saw when we were networking in the morning before I came on screen that we have a lot of our consistent regulars. So thank you for joining us again and being part of what makes these breakfasts successful and such a vibrant, welcoming group of individuals. So appreciate you coming every month. For those of you who aren't quite so familiar with our breakfast, what we do, it's really made up of an amazing group of individuals who we come together to grow professionally, grow personally. We come to inspire and be inspired and network, and just really to bring awareness to what's possible for women in the STEM community today. So that's what we're all about. Obviously, this morning we're meeting virtually, and in 2022 we have been alternating every other month where we're meeting in person and virtually. So thank you for those who came. If anyone is on the meeting today who joined us at the Manchester Country Club last month of May, let us know that too. And I hope you had it was so great to have everybody in person again. And we'll be back there again in July. So hopefully you can meet with us again in July. A couple housekeeping items before I move on. For those of you who aren't familiar with this platform, right now, you probably see you have a box of me in one window, and then there's a box with the slide. If anytime during the presentation today, you choose to see the slides in full screen mode, you'll see 4 little white arrows in the corner of the box. Just click on those and you'll be in full screen mode. And don't worry, you are all on mute and you are all off camera. So sit back, have your coffee, eat your eggs, and enjoy the breakfast in today's presentation. The Tech Alliance events and social media. So take a screenshot with this with your camera so you can take note of it. If you're curious about any of the other events that we have, you can go to the NewHampshireTechAlliance.org/calendar. You can see all the wonderful events that the Alliance puts on, and you can even download it into your Outlook calendar, whatever calendar you use. And this presentation will be recorded, so it'll be on the New Hampshire Tech Alliance's YouTube channel probably in a couple days or so, so you can go back and reference this or any of our other virtual breakfasts. They are all posted on the YouTube channel. And I wanted to make note, 7 years ago today was kind of an important day for us here at the Tech Women Power Breakfast. And take a quick guess on what you think might have happened 7 years ago. Well, it's our anniversary. So 7 years ago today was our very first breakfast that we had in the Manchester Country Club. And it was 7 years ago, I think last April, where we had the brainchild and a bunch of us came together and brainstormed this. And we've been running very successfully ever since. So just wanted to make note of that. Happy anniversary to everybody who's been involved in the last 7 years. The series of our breakfast series is made possible due to our sponsors. And the benefits of being a sponsor, in case you may want to approach your organization about sponsoring, you do have the opportunity to speak at the event. Your company name is included on all our press releases prior to the event. And it really obviously highlights your company's commitment to supporting women and girls in technology. So if you're ever interested in sponsoring, please reach out to me or one of my committee members. With that said, I want to thank and welcome Rise Private Wealth Management and Katie Geary, who is one of my committee members, is going to come on and tell you all about Rise Private Wealth. Thank you, Katie.
Thank you, Heather. Good morning, everyone. Like Heather said, my name's Katie Geary. I work at Rise Private Wealth Management as a financial advisor. For those of you who have been able to join us in person, we're actually right up the road from Manchester Country Club. I wanted to spend my few minutes today to just talk a little bit about what's going on in the markets, because I know there's a lot of chatter, there's a lot of volatility right now. If you've looked at your 401k, it's probably down this year. So I wanted to just give a few key points of kind of what's happening. And I'm going to just post an article in the chat for people to read if they want to learn a little bit more about what's going on. But there's really a few key factors driving markets right now. One is inflation, right? We've experienced that at the grocery store, at the gas pump. We're feeling that in our pockets right now. So what's happening is the Fed's trying to constrict fiscal policy and get some control over that. So you're seeing rising interest rates, right? So you feel that if you're going to go get a mortgage, a year ago it could have been you're going to get a 2% interest rate. Now you're at like 5.5, right? But the other part of that is that companies have a harder time borrowing money right now. It's harder for them to get cash. So you see in the markets that reflected in their earning potential and their forecast for what they're going to earn in the next year or so, because money is more expensive to borrow right now. Other big things happening, the war in Ukraine, right? That's causing a lot of volatility and uncertainty in the European markets, which is hurting international equities. And then lastly, COVID is still going on, right? We're still in a pandemic, an endemic. And specifically in China, China has a zero COVID policy, which means that if anyone gets COVID, they can't work. They can't go to the factories, which causes supply chain issues. And many of our companies are reliant on China. So those are some big things that are really causing volatility in the market. The one thing that I will say is that if you look over the past 42 years, so back to 1980 in the stock market, within each of those years, the market was down on a day of the year, an average of 14%. But the positive side of that is that of the 32 of the 42 years, overall, the market performed positively. So my message to everyone is that, volatility is normal. There's just a bunch of different factors that are causing that right now. And the most important thing is that you have a game plan for yourself and your family to know how to weather the storm. So that's what we help people do, is kind of weather the storm, figure out what this all means, what this means for you personally. So I'll leave it at that, but I will post a link with just a quick article if you want to learn more about what's going on in the markets right now. And if you have any questions, my contact information is on there as well. So thank you, Heather, and the Tech Women and Tech Girls Power Breakfast for having us. We are happy to be here.
Thanks, Katie. And as you can see on the screen, you could take your camera out, and there's a QR code there if you want to schedule time to meet with Katie, just to chat more and learn more about what they're up to. And I want to make note that Rise has been sponsors quite a few of our breakfasts. They sponsored last month. We were in person, and they had really great giveaways too. I use the mug all the time, and actually my husband and I have been fighting over the mug. But thank you for being a strong sponsor of our breakfasts.
Absolutely, thank you.
So if you have any questions in regards to the breakfasts or sponsoring or anything, these monthly breakfasts do not happen if it wasn't for the women you see in front of you on the screen: Shannon Herman, Ping King, Katie Geary, Caitlin Griffin, and myself. So if you have any questions, please reach out to one of us, and anyone would be happy to help you out. With that said, I have the pleasure of introducing our speakers today, my colleagues from Franklin Pierce University. Catherine Owen Koning is a professor of environmental science at Franklin Pierce University in Rindge. She received her BA in biology and environmental studies from Bowdoin College, her MS in ecology from the University of California at Davis, and her PhD in environmental studies from the University of Wisconsin. Dr. Koning teaches environmental science, wetland ecology, water resources, and sustainability. Her current research focuses on water quality management in lakes and wetlands, and exotic species invasion in forested wetlands. She has recently published a book about wetlands, Wading Right In, Discovering the Nature of Wetlands, and is currently working on another book focusing on saving biodiversity. On the Franklin Pierce campus, she helped initiate the Institute for Climate Action and serves on the board of the Monadnock Sustainability Hub. Both organizations seek to find and implement solutions to the climate crisis. And Koning lives in Keene. Pardon me. And now I'd like to introduce you to Frederick Rogers. He is a professor of geology and environmental science at Franklin Pierce University, and he received his BA and MS degrees in geology from UMass Amherst and his PhD degree in geology from the University of Iowa, with a focus on paleontology. Dr. Rogers teaches introductory geology, oceanography, meteorology, and environmental geology, and evolutionary biology. His research focuses on paleontology and biostratigraphy and Devonian age microfossils. He has a long-standing interest in the causes of extinction, the big five mass extinction events in Earth's history, and our current biodiversity crisis. He's a member of Franklin Pierce University Institute of Climate Action, and he is, and for the town of Rindge, he's a member of the Rindge Conservation Commission. So please give a warm welcome to Catherine and Fred.
Good morning, everyone.
All right, so thanks everybody. Ready for me to share our screen? So
Set to go.
see if I can get this up here. Well, easier said than done. Okay. All right, are you seeing the slides now?
Yep, and that's up.
Good to go.
Okay.
Yep.
So Fred is going to start it off, and then I will take over. So go take it away, Fred.
Okay, good morning, folks. And again, thanks for having us here today. Good to be with you this morning. As you can see, the title of our talk here is Climate Change, Evidence and Impacts. And I will be presenting here first in regard to the evidence for climate change and some of the implications of that. And then Catherine will be coming on board to talk about what is being done and what should be being done in regard to mitigating the effects of this ultimately. So ready to go here. I think it's worth looking at this mission statement for the Institute of Climate Action here at Franklin Pierce, which we're both part of. Catherine's one of the co-founders of it, in fact. And it kind of summarizes why we're here talking about this today. And let me take you through this for a minute here. Global climate change poses an unprecedented, urgent challenge to the natural environment, to the quality, even the continuance of human life. Franklin Pierce University's Institute for Climate Action seeks to raise awareness of this challenge and promote efforts to meet it. So it really is a global issue here that we're talking about. And this talk today is part of this piece of trying to raise awareness of this challenge and as it says, promote efforts to meet it. So climate change then, okay, what is it and what are the implications of it? Okay, so let's take a look at that. I'll kind of summarize some basic aspects of this. So climate changes, it's a number of things, obviously, but it's changes really in the lower atmosphere, this lower portion of the atmosphere that we call the troposphere that we live in here. So it's like the first 6 miles above the Earth's surface. Changes in that lower atmosphere and the long-term patterns of temperature, water vapor content, cloud cover, precipitation, storm frequency and intensity, basically all the parameters of this lower layer of the atmosphere that we live in, where the weather occurs, okay, and ultimately where long-term climate change occurs as well. So we can go to the next slide here. And I think this slide kind of summarizes that in a rather nice way, visual way here. And you can see there from the colors, the warm colors, the reds, the oranges, this was sort of the hot regions of the planet here, and then we grade up to higher latitudes, north and south, into the cooler colors. But what this is really conveying is that these warm areas, these hot areas, okay, are getting hotter, and that hot zone is expanding both north in latitude and south in latitude as time goes on here, as the planet as a whole heats up. And we go to the next one here. So what drives the recent and ongoing changes in climate? Okay, there are a number of greenhouse gases, okay, 3 examples of course, carbon dioxide, water vapor itself, methane, all of these, but it's really carbon dioxide that is our main concern. Although, as we'll see, we have a looming issue with methane as well, and I'll get to that in a little bit. So on to the next one. Okay, so again, what drives these changes is really the burning of fossil fuels ultimately. Okay, and we mean by that, of course, coal, petroleum, and natural gas. Coal, of course, is the basically remains of ancient plants that kind of distill down to the carbon. Petroleum and natural gas, actually the remains of ancient marine organisms, as it turns out. But in those cases, we're talking about carbon chains, molecules of carbon atoms linked together from the simplest one, methane, one carbon, or hydrogens around it, to things we call tar and asphalt, which are hundreds of carbons long with many hydrogens attached and other elements attached as well. But in any case here, for coal, petroleum, and natural gas, when you burn them, you're oxidizing the carbon in them, and you're producing carbon dioxide. So the burning of these increases the levels of carbon dioxide in the atmosphere. Okay, much beyond, since the Industrial Revolution, much beyond the natural inputs of carbon dioxide into the atmosphere. So this enhances the greenhouse effect and raises the temperature of the lower atmosphere. And this, of course, symbolizes what I'm talking about here. These four smokestacks, billowing smoke, billowing not just particulates, but among other things, carbon dioxide and some other greenhouse gases as well. And we can go on to the next here. So this is the greenhouse effect, or a little chart summarizing that. And you can see in the upper left, we've got the sun, and that solar radiation then is coming into the Earth. And some of it is reflected by the Earth and the atmosphere. About 30% overall is a global average, but most of it, about 70%, is absorbed at the Earth's surface. And as it turns out then, as we heat up the surface, the Earth itself re-radiates some of this heat energy back towards space as infrared radiation. But as it turns out, though, some of that is captured by the carbon dioxide and other greenhouse gases and re-radiated back in all directions, actually, but some of that coming back towards the Earth's surface, thus heating the lower layer of the atmosphere in the process. So the more carbon dioxide and other greenhouse gases you have in that lower part of the atmosphere, the more it's going to warm up over time. And this next slide will show that same thing, the greenhouse effect again, but maybe just a little more clearly, a little more simplified version. There's a solar radiation coming in, warming the Earth's surface. There's some of that being re-radiated back to space there, but there's that interception in the right portion of the diagram there. There's an interception of that outgoing infrared by the carbon dioxide and other greenhouse gas molecules, which then re-emit that in all directions, some of it coming back down towards the surface and warming this lower layer. So we go on to the next one here. It's the relationship then of carbon dioxide in particular and global temperature that is what we're looking at here. Okay, so this relationship is demonstrated by an analysis of the Vostok Antarctica ice core and more recent direct measurements of the past 100 years. And we'll look at the Vostok cores next, and then that business of the last 100 or so years. So this is the Vostok ice core. This is from Vostok Base in central Antarctica. It's core down through the Antarctic ice sheet, and it turns out that ice is a big friend of us who are interested in climate, because what happens as ice forms, it actually traps little bubbles of the atmosphere at the time it formed. And we're now at a point where we can analyze the gas in these little tiny bubbles, the proportions of the gas in there, and actually analyze the amount of the different gaseous constituents in that. And we can actually track carbon dioxide levels through time here from these ice cores. And what you're seeing here, we're going back, as you can see here, about close to 500,000 years here, 450,000 years. And I think this core goes back at least 1 million, actually, showing a similar pattern. But you can see the close tracking of carbon dioxide in the blue and atmospheric temperature in the red there. Okay, carbon dioxide really is a driver of global temperatures, and this is data, from way before the Industrial Revolution, hundreds of thousands of years before. So there is a correlation there that goes on. And then if we look at the last 100 or so years, the next slide, we can see what's happened, in this our industrial times here. This is going back to 1880. It only goes up to 2013 in this slide here, but you can see that tracking of carbon dioxide and temperature here that's going on in the last 100 years or so. And if we extrapolated this out to 2022 now, 9 years later after this, you'd see that curve going up even more sharply, more steeply, above 400 parts per million. So we can go to the next here. So what are the effects of all this? What are going to be the consequences of this? Okay, so temperature affects all the other important aspects of climate. It affects those things I mentioned earlier on: water vapor content, cloud cover, precipitation, storm frequency, and intensity. Okay, it affects all those factors that we were talking about in terms of weather and ultimately climate over the long term. And we can take a look at some of these effects here. Here with the next slide. Here's kind of a list, not absolutely exhaustive, but a pretty substantial list of some of the things that are going to go along with climate change. Okay, some of these changes include wetter tropical regions, wetter than they are already, drier and more expansive subtropics. Okay, so we're going to have actually expansion of the dry areas and desert regions, rural, semi-arid and arid regions of the world, which is problematic for the people living there in terms of water supply. Thawing permafrost, that's going to be a big one because that's going to be releasing methane from those permafrost areas, which is even more potent greenhouse gas than carbon dioxide. Melting polar ice and sea level rise, half the world's population, 3.5, 4 billion people are on the coastlines. Okay, this is going to cause some real issues on coastal settlements, various kinds, including many major cities. Ocean acidification, that is going to affect especially larval stages of many marine organisms, many of which are of great interest to us in terms of food supply. Altered geographic ranges of microbes, plants, and animals. Okay, and there'll be some pathogens that might be moving to higher latitudes that we have not encountered here before. Another problem with this warming of the Earth that's going on. The end and extinction of species. There'll be some that will not be able to adjust to these climatic changes, and especially in conjunction with some other things that are happening, like loss of habitat area and so on and so forth. And then threats to human comfort and health. Okay, I mentioned the migration of microbes. That's one thing, but it might be a little uncomfortable as well in other ways. All right, on to the next slide. And here's the implications for biodiversity of this global warming if we have a 1.5 degrees centigrade rise here. Not sure why that is going like that, but I think it stabilizes here on 2 degrees centigrade. Okay, hopefully it'll stay on that. Yeah, keeps going back and forth. Not sure why it's doing that. It was not doing that on mine.
It's funny, it doesn't do this when we look at it ourselves.
Yeah, I know, it's fine, but at any rate, maybe we should keep it on 2 degrees centigrade. I think it'll stabilize it too.
Okay.
Because this is what we're going to try to avoid, is getting up to 2 degrees centigrade, because we're going to be seeing a degree of warming where we have, 1 out of every 10 years on average, ice-free Arctic Ocean in the summers. Okay, unprecedented there. And along with that, if you kind of follow along from left to right there, from the ice-free Arctic summer to the next piece, limiting warming to 1.5 centigrade rather than 2 would prevent the thawing over centuries of 1.5 to 2.5 million square kilometers of permafrost area. And so we want to avoid that, because this is where you're going to release methanes from these molecules called methane hydrates that are locked in the permafrost. And the methane is 25 times more efficient at capturing infrared than carbon dioxide is. So substantial release of methane is going to be very problematic, ratcheting temperatures up even faster and higher than they would otherwise. And we're going to have a big impact on coral reefs. There's going to be a major decline, almost 100%, that would go on with this 2 degrees centigrade rise and an enhanced ocean acidification as well, which is going to affect especially the larval stages of many marine organisms. And we're going to have changes in the timing of various biological events, like when the leaves flower in the spring with pollination, and so on and so forth. And it's not entirely clear what effects that's going to have, but it's probably going to have some negative effects there. Alpine species are going to be finding themselves more and more limited in their ranges as they have to move upslope, stay in their climate zone. And we are anticipating a fair amount of extinction, 18% of insects, 8% of vertebrates, 16% of plants, or at least big impacts on a high percentage of these different organisms on the planet with a 2 degrees centigrade rise in temperature. All right, I think we'll go on to the effects on our health here. Okay, so rising temperatures then are going to have a number of effects. Okay, there's going to be more frequent heat waves, heat events, especially in cities, which are urban heat sinks. As it turns out, they even get hotter than the surrounding countryside, leading to those things you see at the bottom of the slide there: dehydration, heat strokes, aggravating cardiovascular, respiratory diseases, and so on and so forth. And you can see here around the center of that slide some information on the impacts this sort of thing has had already. At least 37 states then have experienced record temperatures in recent years. There's been several thousands of deaths that are heat related and projected many, even hundreds of thousands more in the future as temperatures warm over the coming years. And children, the elderly, and poor in particular are going to be particularly impacted by this. And I think we could say safely, since this slide was made about a decade ago, I think there's been even more states that have experienced record heat. There's been even more heat-related deaths, and the projections would be even a higher number of potential deaths in the future as things warm up here. So we can go to the next here. And I think this kind of summarizes, in a way, visually, some of these things we talked about. You're all familiar with the wildfire issues that have been going on in the American Southwest for some time, American West in general. Australia recently as well is over here, and the tremendous water issues that have occurred out in the American Southwest as well. And there's a lot of the lakes, ponds, reservoirs, and so on that are drying up, are totally dry and mud cracked, as you see here. Okay, the situation is becoming critical out in Southern California, as it turns out. And we're seeing a greater frequency of cyclonic storms, hurricanes, and so on. And the winds may not be necessarily particularly that much stronger than in the past, but the rainfall is becoming more intense with these events as we go on here, creating their own problems with flooding associated with these storms and so on. So we're seeing a number of impacts around the country, around the world here from this warming. And as I was just talking about, projecting into the future, a 2 degrees centigrade rise is going to accentuate these issues even further. Okay, so we can go to the next here. And I think this is my parting shot, as it were. Time is short. We really do need to severely reduce carbon dioxide emissions, okay, to about 1/2 2010 levels by 2030, 8 years from now, and go to net zero emissions by 2050 to hold the line at that 1.5 centigrade rise in temperature, rather than getting to that 2, which is going to be particularly problematic. So I think that's my piece here about this, and we're going on to action, what we need to do to address the problem, and I will turn it over to Catherine at this point.
Okay, well, I don't know about you guys, but I'm thoroughly depressed right now. Ready to take action. I think Fred did a nice job of laying out why we have to keep the temperature to 1.5 degree increase and no more than that. So we're going to look at the different actions that can be taken. And I have the logo from the Monadnock Sustainability Hub up here, in addition to the ICA, Institute for Climate Action logo, because some of the information I'm presenting has come from my work with them. So One thing I want to show you, it's pretty exciting. So we've all heard lots and lots of possible solutions that have been proposed. Our scientists and engineers and policymakers have been hard at work. But how do you decide how much of each thing to do, right? How much will get us? It's all very quantitative thing. So the really smart folks at MIT have put together this dashboard, this interactive dashboard that allows us to use real data and real scenarios to figure out what needs to be happen. So this is based on extensive literature search and data that's put together, kind of putting all these systems together. So I'm actually going to exit out of PowerPoint for a minute and take you to the dashboard, if I'm competent enough to do that. Anyway, are you now seeing this En-ROADS dashboard that says 3.6 degrees?
Yep.
Okay, cool.
Yeah.
All right. So you guys can go to this yourself if you want to play with it while I'm talking, or just kind of listen along. What this dashboard shows is our global sources of energy: coal, oil, gas, the fossil fuels, renewables, and other sources. And then the net greenhouse gas emissions. So it has historical data up to 2021, I believe. And then after that, it's projected based on the very extensive modeling going on in here. And what we're going to be keeping our eye on is this over here. We want that what is projected to be 3.6 degree increase by 2100. If we just keep going with what we're doing now, we want to get that down to 1.5. So how do we do that? If I could hear you all, I'd ask you to give me ideas, but I can't. So I'm going to give you ideas. So we can use these sliders to say, well, we know burning coal produces greenhouse gases, so we're going to decrease it. You can see the mechanism that would be used to try to decrease it, in this case, is taxation. So this is the status quo. If we increase it, that we could do that by subsidizing, through tax incentives or government payments or whatever, or we can tax it. All right. You can see when I do that, you can see the amount of coal burning goes down. All right. There's other mechanisms that the model allows you to do. If you hit these little 3 buttons, it allows you to just shut the coal-fired power plants down. Many mechanisms. All of the different things have various mechanisms. But we're going to play with these mechanisms right now. So let's say we're going to shut oil down or highly tax it, and that's going to reduce the demand for it. We're going to reduce the demand for natural gas by highly taxing it. All right. So you can see, okay, this is dropping. This is good. Our greenhouse gases are dropping, but we're not much closer. We started at 3.6. Now we're down to 3.1. We got to get to 1.5 degrees Celsius future increase. Bioenergy, well, that's burning wood pellets, garbage, other things that we can burn, but they all produce greenhouse gases. And so we want to decrease those. So we got a little more decrease there. We want to increase our renewables. All right, so we saw the proportion of the green, which is the renewables, go up. We saw the greenhouse gases go down, but we're not there yet. Nuclear, pretty controversial, but in terms of greenhouse gases, it doesn't produce greenhouse gases. So we can say, well, let's increase it, see if we get anywhere. Doesn't make much difference. You can see a little bit of change, but not much. All right, but we'll leave it there. We're going to increase nuclear. This category, new zero carbon, is so that you can play with new imaginary technologies. This is things that aren't invented yet or are still in the development stage. We're going to leave it alone. Carbon pricing is something we're going to talk about. This is a way of incentivizing, a different way other than taxation, incentivizing low carbon emissions. So let's see what happens if we put a price on carbon. You can see a big impact there, right? A little bit more than, but we're still not there. So now that was all energy supply. Now we're going to look at transportation. What can we do here? All right. Well, we want to make our transportation more energy efficient, smaller cars, lighter cars, more energy, better gas mileage. Or we can, now that we've got a lot of renewables in our energy supply, we can electrify. All right. So a little bit of difference, not much. Same thing in the buildings, more insulation, more energy efficiency in our buildings. That gets us places. Electrify our heating systems, electrify everything we can. Little bits of differences. Population, how many people obviously affects how much greenhouse gases. So population, if you increase it, that's going to take our temperature in the wrong direction. If we decrease it, it's going to go in the right direction. Really controversial. I'm going to leave it alone. Just so you know, you can play with that. Economic growth, same thing. More economic growth, people are buying things and creating those things, unless it's the service industry. Creating those things produces greenhouse gases. And then decreasing economic growth, all right, takes us in the right direction. I'm going to leave that alone too. Our land and industry emissions, there's deforestation, obviously cutting the rainforests and other major forests has accelerated the production of greenhouse gases because those trees are no longer taking in carbon. So if we decrease deforestation, that's going to help us. All right. All the other greenhouse gases, methane coming from cattle production, coming from leaky gas pipelines, coal mines, other sources, that's important. And fluorinated refrigerants, those are also greenhouse gases that escape. And nitrous oxide. So if we decrease those other ones, and again, you can dig into it and see what specifics we're talking about on any of these things, or you can just play with this kind of more macro look. And we're going to say we're going to, through many different methods, decrease that. And we're getting closer and closer. All right. Another thing we can play with is afforestation, so planting trees. Little controversial because a lot of the afforestation that's going on is on places that grow food. There is some controversy, but you can see as we start planting trees, oh, we're getting there, we're getting there, we're getting there. We're so close. All right. And then this category, technology, is all different forms of carbon capture and storage, not related to coal and oil, natural gas, but other forms of things. And again, you can dig into it by pressing on this dots. But if we increase our different forms of carbon removal, the technologies, now we can get to even better than 1.5. All right. So this is a really fun tool to play with, and I'm going to set it back to the status quo. And just to show you one thing, look at how before we're able to get some big change with carbon pricing, but look what happens if we only change carbon pricing. All right, because remember, these we were doing here was taxation, which is a market mechanism, but carbon pricing by itself gets at a lot of things. All right. So it has a big change. Still doesn't get us all the way to 1.5, but carbon pricing by itself can make a big difference. So did that all work, Fred? Were you able to see?
Yeah, it worked.
Okay.
Yeah.
All right. I'm going to go back to the PowerPoint. All right. And hopefully that will work. Are you seeing the PowerPoint now?
Yeah.
Okay.
Okay.
So I can't see the chat, but Heather's going to read out to me what's in the chat. So based on that En-ROADS simulation, that MIT model that I just showed you, tell me what you think, what was the take-home message you got from that simulation? Type some things in the chat and let me know what you think. Heather, are you seeing any thoughts there?
Not yet. While I'm waiting, I'll make my comment while I'm waiting for people to type in the chat. First of all, I thought that simulation was very, very cool. But what surprised me about it was just how certain things could make a big difference and other factors made absolutely no difference. It also made me think, when they talked about taxation, made me think about, well, that's sort of an assumption that highly taxing oil or some of the other factors would decrease demand. I feel like that's a little bit of a gray area, but I understand for why they put that in the simulation, because I feel like that's making an assumption that's going to decrease demand. But
yeah, I mean, I think they're based on the economic models. But yeah, it's a model, right? It's not going to be perfect.
right.
Right. So in the interest of time, I'll tell you what my take-home message was. All right. That there is no silver bullet, right? You saw that I had to move almost all the levers to get some change. All right. And so people who've been working on this says, well, there's no one silver bullet. It's really silver buckshot, right? We have to do everything, right? So we have to decrease fossil fuels, bioenergy, decrease deforestation, decrease population size. We have to increase renewables. We have to explore new technology and implement some carbon renewals. And so what I want to talk about now is, well, how do we get these technologies implemented? I think you probably did see that one of the most powerful actions we can take is really a policy and economic incentive. It's carbon pricing. So I'm going to talk briefly about that. And then once one other goal we have is to decarbonize the electric grid and electrify everything. And so we'll talk a little bit about some technology around that. Okay. I'm hoping to get to some time to have a little discussion at the end of breakout room, but we'll see how the time goes here. All right, carbon pricing. So carbon pricing, a lot of you are probably fairly aware of it. It's one of the key policy changes that will allow us to decarbonize just about everything. Once we put a price on carbon through a fee on fossil fuel production or through emissions trading, we've created a market-based incentives to reduce greenhouse gas emissions, right? So companies are going to seek to avoid the pricier carbon fuels and look to renewables or energy efficiency. And it also incentivizes the development of new technology. You can see from this map here that carbon pricing is not new. 72 federal, state, or regional governments have some form of carbon pricing, including New England. We have the Regional Greenhouse Gas Initiative, which is an emissions trading scheme. But I'm sure you can see that, this right here, price goes up. No one wants to hear about prices going up. It's inflation. It's not popular, right? So that's why the fairest and most equitable way of doing this is through what we call a carbon fee and dividend, where the fees are returned to the public as a dividend. And so the studies of this have shown that in the US, through this kind of system, about 85% of the population, including all lower income people, will get more money back than they paid into the system via increased prices. Now, I'm not an economist, so I'm relying on the economists who studied this, but that is what they've come up with. All right. So that's one form of carbon pricing. The other one that is shown in blue are emission trading schemes, and this is like a cap and trade system where different companies are, in our area, it's the utilities, are told this is the max amount of greenhouse gases you can produce. That's the cap. If you want to produce more, you're going to have to basically trade away your permits to pollute. And that creates incentive for them to decrease their greenhouse gas production. All right, that's a little more complicated than that, but it's been very, very successful in controlling pollutants like sulfur dioxide, and it had a lot of success around the world. There's a lot of controversy about it, but I mean, more about carbon fee than about the emission trading system. There is a bill that's been proposed in Congress to have a carbon fee and dividend system, and it's going nowhere. So given that it's going nowhere, well, how do we move forward? We can't sit here and just throw our hands up and say, well, we can't do anything. So there are some things that we can do, every single one of us in the room. And I'm not just talking about light bulbs. All right. I'm talking about something that's called community power. All right. So community power is a relatively new system. And basically what it is bulk purchasing. So allows towns, each community, city, or county, to bulk purchase electricity on behalf of its residents. All right. So that basically gives them access to wholesale electricity prices. So many of you probably work for large companies that can have enough demand for electricity that they work with a broker, and they can get electricity at wholesale prices. You and I, for our homes, we can't get that. So if you or I want to have clean energy, we have to pay a lot of money to put solar panels on our house. Maybe we can't afford that. Maybe our house isn't the right place for solar panels. So community power allows us to come together and do this. So 9 states have community power. And basically, like I said, with the consent of the people in the town comes up with a plan, and the plan has to be approved by the Public Utilities Commission. And that allows the city or the town to negotiate for electricity. And they can get it at a lower price. They can specify how much renewables they want in their mix. And the important part is that the public utility would continue to deliver the power. All right. What's really exciting about this is that in the states where this is really new in New Hampshire, in the states where they're really already doing this, what they've done is they've found a way to implement new programs and services related to clean energy and energy resilience. So what some towns have done is they've added a teeny little surcharge, a fraction of a penny. And again, this is with the consent of the residents to provide funding for low-income homeowners to make their homes more energy efficient, to put in locally produced renewables, to have battery backups, to work on climate resiliency. So New Hampshire is new to it, but there's already a lot of towns, as you can see, that are on board. All right, so a good number of them have passed plans. And a whole bunch of, I was just at a meeting last night with a whole group of people who either passed plans in the Monadnock region or are working on it. And if you're interested in this, these 3 groups are all working on that. So this is something we can all do. So this is actually your homework for the day. All right, is that, you can get information from this website here, and once you feel like you kind of know what's going on, you can go and talk to your representatives in your town and try to get them to get on board with community power. So once we have cleaner electricity, all right, then we can start electrifying everything, right? And so that's when, okay, our electricity is clean, but I'm still driving my gas-fired car. But now you can have an electric car and feel that it is being powered with clean electricity, because 27% of the U.S. greenhouse gases come from transportation. Every time I present this, people are all over me going, "You're such an elitist. Not everyone can afford an electric car." Well, this website shows a whole range there's many models. I'm just showing 3 of nice low-end cars. I've got my eye on the Nissan Leaf here, right? $25,000, 226 miles on a single charge. And yeah, if you want to get a Tesla or something even more fancy than a Tesla, you can. The Monadnock Sustainability Hub in the Monadnock region, we're trying to talk to different police departments about switching over to EV police cars. Other places in the country have done this, and they save money. All of these cars cost less over the life of the car to run than a gas-fired car. And when you think about how much money you're putting into your tank right now, it probably sounds pretty good. We're also working on electric school buses. Obviously, one of the big problems that we have is getting New Hampshire needs more charging stations. So that is something that a number of us are working on, and that is something that you also can try to motivate your town and your business-friendly friends to get involved with. One thing you can do at home once we have a nice clean electric grid is, I don't know about you, but in my house we heat with wood and oil, and I am tired of stacking wood. And I'm tired of paying high oil prices. Our oil tank is actually empty right now because we refuse to pay for the oil. So fortunately, we have electric hot water. So anyway, so heat pumps, I'm not going to go into the details just for time, but heat pumps allow you to both heat and cool your home. And they can be ducted or ductless. Here is the inside look of it, and here's the outside look of it. And they work even in New Hampshire. They won't work on the coldest days, like lower than 20 degrees. So you're still going to need your other furnace occasionally. But we have these in our house, and we like them. All right. I think I'm just going to quickly show this. What we're doing at Franklin Pierce. We put in wood pellets back when we thought that was the right thing to do. And now we have the energy efficient windows and boilers and a lot of efficiency. We recently put in a big photovoltaic system, solar panels, and all the new construction is getting those heat pumps I just talked about. Right. So we were going to try to do some breakout rooms. Heather, do you think we have time to do the breakout room? Or should we just go to
The one for just under 10 minutes? Maybe we could break out for like 7 minutes.
Okay. So these questions, Heather's going to put these in the chat. We're going to ask you which of these different action intrigues you the most. We talked about carbon pricing, community power, electric vehicles, heat pumps. Are there other ideas? What do you think is the most important action you can take? And what's the biggest obstacle to implementing those actions? And what could we do to help you overcome them? So I'm going to figure out somehow how to stop the sharing. If I can.
I could, and then, so we're going to break out, and as everyone knows, you'll just be put into a table. So if you happen to be in a table by yourself, just join another table. The tables have limits by the chairs there. So, just pop into, another table with someone if you're not already, if you're only by yourself, and I'll pull everybody back in a few minutes. So everybody, hopefully, I didn't cut you off, but just for the sake of time, I know it's so fun with the breakouts chatting. So Catherine and Fred, you can just turn your cameras back on and join me back on stage, and we can discuss our the breakouts.
There we are.
I'll hand it back over to you, Catherine.
Well, does anyone have anything they want to share as what they thought was the most important action that they could take from today? Any thoughts?
Feel free to type it in the chat.
What did you find the most intriguing, interesting, whether or not you could be involved? Everyone's feeling quiet. I get it. Yeah, just to make you feel a little better. I don't know where you're all from, but a lot of you, the work is being done by your elected representatives or your volunteers in your community. People could type in the chat where they're from, and I could tell you whether or not your community is in the, Lebanon is good. It's community power, community solar. Lebanon also has community solar. It's a different thing. Yeah, there was a drop in greenhouse gases during COVID, but we're right back up. Yep. Tilton and Somersworth, you guys need to give a call to your elected officials and get them to work on community power. And Nashua, you are very fortunate. Your city is moving right along. There's a lot going on in Nashua. And you can thank one of our students for that. Who works in Nashua, Doria Brown. She is helping out a lot. Yeah, carbon pricing. Yeah, there is a political divide. All right. Yeah. In community power, actually, this is very interesting. Last night, a bunch of the towns that are working on community power reported out the towns that got on board early, they did work very, very hard. The towns that, are just coming on now, they said, well, we just copied their plan. And then brought it to town meeting, and it was approved. If your town is so small that it doesn't have any staff, then you are looking at a problem because someone has to negotiate with the service provider. But it is a service provider that does all the real work for it. So, Gary, go ahead, Fred.
Oh, sorry. I was just going to say in my group, I think that was Star, Michelle, and Valerie. I was chatting with, I think the community power idea seemed to be the one that had the most resonance, excuse me, there. And I think that's something that a lot of people will kind of latch on to when they hear about that. That seems to make a lot of sense.
Yeah.
That direction, yeah.
Yeah, and I mean, Derry's a big town, and that is a place, Lisa, that, just take a minute to call your town administrator or whoever it is that you know in the town, and just say, why aren't we out working on community power? Or put it to your Concom and see if you have one. But in some of the small towns, you can latch on with a larger town. You still have to have a plan, but at this point, the plans, you could just borrow one, change the words. And it's a great system. It basically, you're still going to get a bill. It looks just like your bill from Eversource, but the electricity will be coming, through Eversource. Eversource will still maintain the poles and wires or whatever it is you have, Unitil. But the electricity will be cleaner if that's what your town chose to do. And people can opt out if they don't want it and they want to just go back to Eversource or whatever, they can do that. So even in a conservative town, what's nice about it, it's local control, which is, conservatives like that. And you can say, the town could say, we don't care about greenhouse gases. We only want cheaper electricity. But, over time you could sneak in the renewables. So there's a lot that you can do. And again, if you're sick of stacking wood and paying high oil prices, check out heat pumps. Even if you're ahead of the game and you electrify your energy in your house now, once the grid starts changing to more renewables, you'll be all set. They're very heating and electricity in one thing. It's very cool.
Catherine and Freda, a question came in. They were asking, they said, is the in-road simulation showing what would happen worldwide if the United States did this? And then wouldn't other countries possibly counteract any good we try to do?
So it's a global model. So it's not looking at just at our policy. It's like if everyone did carbon pricing kind of thing, right? So it's not just saying what's going to happen in the world based on what the US does. So it's a global model. But as I was saying in the group I was in, carbon pricing, the way it's proposed for the United States and the way it works in places that have carbon pricing, there's a border adjustment. So if, there's cheap oil coming from some other country that didn't have to pay these carbon fees, they'd have to pay it when it came into the US. And that would drive innovation in other countries as well. And so carbon pricing in the US, because we buy so much stuff from other countries, will drive the whole world, potentially to, or a lot of it, to switch to more carbon neutral energy sources and production means. So it's pretty exciting, I think, but we have to kind of wrap our minds around it. And it's pretty hard to propose anything that affects prices right now, but maybe going forward, it's a very powerful tool. Meanwhile, we can all do community power, heat pumps, look at electric vehicles.
One last question before we have to wrap up. Jane was asking, she's really looking forward to solar powered cars. We talked about that in my breakout, my table. I was at the table with Jane. She was just wondering if like how far out are these? What have we heard about that?
If you're talking about cars that are literally have the solar panels on them, I'm not really sure that people are really trying to develop that as much anymore. They're here, but not on a large scale basis. Because you have to have such heavy batteries. But they're basically here in terms of electric vehicles, because once our grid is solar powered, like at our house, we are now looking at, once I buy my Nissan Leaf, we're going to put some solar panels on our garage. So I'm hoping to have a car that is charged by solar, right? So it's not going to be driving around with a solar panel on it, but it will be, the battery will have been charged with solar.
Effectively a solar car, basically. So
Right. So it'll be virtually a solar car.
Yeah.
So, and things like air travel, it's probably never going to happen. But they are looking at fuels that can power a plane that are made with renewable energy.
Great. Well, thank you very much. We have to wrap up here. It's 3 minutes before 9. So that was super informative. Thank you both so much. And yeah, we really vary our topics each month. And this was really interesting. And, you know, to your point, Catherine, in the beginning, you know, it is kind of like, oh my goodness, you know, doom and gloom. But I like that you presented us with actions that we could take individually, because sometimes it's so overwhelming that some of us just think, what can little old me do? So I appreciate you sharing actions that we could do and to bring awareness to it. So thank you both so very much. We really appreciate it.
All right. Nice to meet you all. Thanks for the opportunity.
Yeah.
So I'm just gonna share my screen, everybody, real quick before we close out here. So I'll share again one more time. Give me 1 second to share. Okay. So I hope that was informative for everybody. I'm definitely more educated this morning. Learned something new every day. I learned a lot of things this morning, so really appreciate that. Hopefully you join us next month in person in July. We will be again at the Manchester Country Club, July 13th. Put it in your calendar. Please join us. Tell your friends. We're gonna have Kendra Bostic talk about Play, Reflect, Connect, and Grow. She's a PhD student, and she's a CEO and founder of Kokori. And she won an award at the Tech Alliance this winter. So it'll be really a fun event. So hopefully you can join us next month. And again, then August, we will be virtual again. As I mentioned, we are alternating every other month. So with that, hopefully we accomplished our mission to inspire and be inspired. As you know, I keep the room open till 9:30. So if you want to stay around and chat with Catherine or Fred, they're here. So have a great day, everybody. And